For our final project, we decided to expand upon Lab 12 and do some cool things with ray tracing. So just a couple things to note before we dive into some of the work we've done. This is all done pre-rendered on the CPU. There are GPUs out there that can handle ray tracing. It's very computationally intense. Some of these pictures took a while to, some of these images took a while to render. So some future steps could be, how would we implement this on a GPU? So the next important thing here is this sample. So NS, that's our samples. So right now it's at 100. So for each pixel, we have 100 rays that we're simulating through each of these pixels, and we basically average, what these 100 rays should be, and that'll give us the color of each pixel for these images. So looking at some of the work we've done, this is just the cover of the book, the Shirley book, at 1 ray per pixel. So it looks pretty decent, but we got a lot of these black dots here, and it's a very grainy, not very smooth image. So upping it to 100 rays per pixel, we get this really nice looking image here. These spheres look pretty good. We have 3 different materials for these spheres. We have these diffuse materials, which are these solid ones that don't really reflect anything, and then we've got these glass ones that kind of invert the image, invert the ray that's being sent into it. And then we have these metal ones. As you can see, like this big gold one is metal and it kind of just reflects directly back at the ray back right out. So looking at going through book 2, you get into some of these other objects. You get some light source. We have a light at the top here. We've got these rectangles that are these walls. Some solid textures for them too. So after we've got all these lights, cameras, objects, we've got spheres, rectangles, and cubes. We're like, what comes next? What's the next thing we could do? And obviously, our train of thought went straight to these triangles. So once we had to figure out the hit function for these triangles. As we've learned in the class, triangles aren't as simple as spheres and rectangles. So once we were able to get these going though with the hit function, what comes next? Obviously our object models. This is actually the bunny from assignment 3. As you can see, there's some nice shadows in between his legs, around his tail, under his neck. So yeah, this is just, I believe, 1 ray per pixel, I think. So but we still get like a decent image here. So going to 1000, this is 1000 rays in the Cornell box. We threw some bunnies in it. As you can see, we have them rotated a little bit. This one's facing backwards, this one's facing forwards. We've got them translated and scaled. So the only light source is the one at the top, and again, this is 1000 rays for each pixel. This took about 17 hours to render on a Windows computer, just a standard Windows computer. So I mean, it took quite a while to render some of these images, but you can see they look really nice. This gold bunny, he's got the green and the red reflecting off of him from the walls, and that's all being calculated, and they look pretty impressive. Their materials. So once we've got all this, we can start making some cool images of our own. Again, this one's about at like 1000, so again, 17 hours to render on a standard Windows computer. But if you're operating more cores, some of these we were able to get working with the cores in Linux. So based on how many cores you're using, you're basically cutting your computation time there. And we increased the light. We made the light a bit bigger, so that you can see the it looks best on this gold bunny. The red walls reflecting off him real nice and the green off his back. And yeah, you can do some cool stuff and make some cool images with this ray tracing with the models now implemented. So we hope you enjoyed our work.